So we're done the Cartesian to spherical, spherical to Cartesian. It's now time to put in our coordinate transform, which takes place in spherical coordinates because this is a spherical cloak. So it made sense to do that. And we're going to do this in this right in between where we're still in spherical coordinates, right? We have the coordinates from Blender, X, Y, Z. We convert to spherical. This is where we'll do the transform. And then we go back to rectangular or Cartesian, and the wave is calculated. Okay, so let's go ahead and also minimize the space on the right. We won't need to see much here. And on the left, we're going to need to make some room between the rectangular to spherical and spherical to rectangular nodes because we'll put our math in here. Well, the first thing we're going to need is two value nodes. By that, we can set a constant, and that's for R1 and R2. So let's bring in a value node. We'll click on that. We'll label it R1. Then we can duplicate this, and we'll label the second one R2. All right, let's do the transform now. The first thing we'll need is an R2 minus R1. So let's go ahead and add a math node, and we'll set that to subtract. And R2 minus R1, I don't like these things crossing, so I'm just going to switch the order of my R1 and R2. Then we need the difference, this R2 minus R1 divided by R2. So I'm going to go ahead and duplicate the subtract node, and I'm going to change this to divide. And we're going to divide R2 divided by the R2 minus R1. We need to do another subtraction, and we're going to subtract our coordinate R minus R1, and then multiply these two terms together. So I'm going to go ahead and duplicate the divide node. I could have duplicated the subtract node. I'll call that multiply, and multiplies together. And now we have our transformed R. So if we plug this into R, something should happen. It should look very close to a cloak. We're not quite there, and I'll explain why once we do that. So let's cross our fingers and see if we get something that looks close. All right, well, like an idiot, I didn't set my R1 and R2. R1, let's set that to 0.25. R2, let's set it to something like 0.8. And that's looking, it's not a correct cloaked wave, but where we have the math so far is definitely correct. And there's a few things we've done wrong right now. Remember, that coordinate transform should only be done when our coordinate is less than R2. Right now, we're doing it everywhere, and that's why we see the wave bending everywhere, even outside the radius of 0.8 that we set it to. And also, we don't want to see any field in the middle. We need to zero that out. But otherwise, it's correct for what we've done. So we'll go ahead and drag that over and back to work. I think a good first thing to do is to correct the transform outside of R2. So let's just go ahead and drag this work down closer to the lines, and we'll do these comparisons down below here. So let's duplicate any of the math nodes, and I chose the subtract one. Let's change this to greater than, and I want to see when the coordinate R is greater than R2, then what's going to happen on the output of here where it's greater than, I'm going to get a 1. When it's less than, I'm going to get a 0. And that lets me then choose between whether I want to use the math for my coordinate transform or use the original R. So we need the node that's going to make that choice for us. So let's add a mix color node. And I'm going to drop that right here for now. I'm going to move it up. So this is intended for mixing colors, but notice there's a drop-down menu, and we can have it mix floats. And we can use this to choose between whether to use the math from the transform or the original coordinate r. So I'm going to drag the mix node up here. And the output from the multiply node is going to go to the A input, and it defaults to that when you drag it over. This greater than decision, I'm going to drag up to this factor. So this is only going to be zeros and ones, so it's going to choose between A or B. So A will be use the transform math, and B will be use the regular coordinate, which we haven't hooked up yet, which is why it looks all orange and strange. We see the field and the coordinate transform happening inside the cloak, and that's fine, but we need now to drag R over to that second input of the mix node. Now we should see a correct field outside of the cloak, and we definitely do. That was subtle and an easy thing to miss, but definitely an important thing. The last thing we want to do is zero out the field inside the object, inside of R1. So we'll do another comparison. We'll duplicate this greater than node, and we'll keep it set to greater than. And let's look at when R now is greater than R1. When it's greater than R1, this will be a 1. When it's less than R1, it's a 0. So I have zeros everywhere I don't want to see the field. So maybe a great thing to do is to come over after we've calculated our field and multiply it by this, so it will zero out the field inside that cloaked region. So we're going to insert a multiply node here, and let's give us a little bit of room. So I'm going to move this over. I'm going to duplicate the cosine. Let's change this to a multiply. And right now we just want to do a pass through, so I'm going to change the second number to a 1. I'm going to drag the output of the cosine to the first input of that multiply node, and then I'll drag the output to where the cosine was going. And so it's just passing through that for now, and should look the same once Blender catches up with us. Yes. But if I drag this last comparison to that multiply node, it's a long stretch to bring your route, but I'll take the output of that greater than check and bring it to there, and that should zero out the field inside of the cloaked region. And that's everything we need to do. That's looking really good. We can even have some fun with this and play with the phase. Looking really nice. Okay, well, that is it for this video. I'll see you in the next one where we dress this up a little bit.